is any two bodies, there is a force of attraction between any two bodies.
You can write FOA. I'll understand.
Yes. Any two bodies. So simply due to their mass, because they have mass, definitely they have some attraction. So here, as per this law, this is actually defined using the universal law of gravitation, which they said that force between two bodies is directly proportional to product of the masses. Product of the masses and inversely proportional to square of the distance between them, which we'll call it as many like square of the distance means, for example, that particular distance is measured.
Can you repeat the proportional part? I didn't hear.
It's directly proportional to the product of the masses.
Force of attraction.
Yes,
Yes, sir.
and is inversely proportional. Inversely means we'll write 1 by because it's reverse. Reverse.
Okay, sir.
So it is inversely proportional to the square of the distance. Square of the distance means suppose we have two bodies.
Is
We
distance supposed to be D or S?
yes, generally here if it is most of the bodies they are circular or like spherical bodies. Okay, we'll take the radius like we can call it as radius also. That is simply we can represent it with the R also.
Okay, sir.
So here in this particular chapter, the distance between the two bodies is measured from center to center. Means, for example, every body will have there is one point called as center of mass. So for every mass, there will be a center. From that center to the other center, they'll measure it.
Yes, sir.
Okay, that is the distance between the two bodies. So here force is directly proportional to product of the masses. Let us take the masses as you can take M1, M2 or capital M, small m like that.
Yes, sir.
So now we will take it as M1, M2 country, M1, M2, where M1, M2 are the masses of two bodies, and it is inversely proportional to square of the distance between them, as per the person who found out that uh, as the law is defined based on its point, that is directly proportional to product of the masses and inversely proportional to the square of the distance between them, and the distance is measured from center to center of the two bodies. So
Okay.
finally, when we write both these when we write it together, it will become M1 M2 into 1 by R square, which is M1 2 by R square. Means this happens at a time. That's the reason why that is the meaning of this particular thing. When we club it, both of them together means meaning is like that happens at a time. At a time, it is proportional to product of the masses, and also at a time it is inversely proportional to the square of the distance.
Yes,
So
sir.
that is when we club it and write it. I mean, now generally in any equation, if we remove the proportionality, we'll get a constant. So if we remove that proportionality constant, here that f is equal to, we'll get proportionality will go, we'll get some constant k into m1 into by r square. Here k is given as g, capital G. The universal, we'll call this as universal gravitational constant.
Sir, why did you put K there?
Generally, Pranavi means in any proportionality, constant will say. No? If we remove the proportionality symbol, we get an
Like,
equation.
like when F is proportional to MA, we remove the proportionality and write F is equal to K into MA.
Yes, Pranavi, like that. Then in that case, k is 1. Like
Okay.
we'll get finally f is equal to m.
Yes.
Any proportionality, if we remove, we'll get a constant multiplied with the right side thing. So that constant, as per that here in this situation, that constant is given as g, which is called as universal Means every proportionality equation will get a constant. In general, we'll represent that constant with k, and as per that situation, what is that k, we'll write it.
Okay, sir.
K means generally it's a constant. So any proportionality equation, if we write an equal to, then it follows with a constant with the right side. So,
Yes, sir.
actually, our video is off. So here in this particular case, k is given as a g, which is universal gravitational constant. Universal gravitational constant. And that particular value also is given as 6.673 into 10 power minus 11.
6.67 into 10 power minus 11.
The third decimal also, if you write it,
Sir, actually, in the books, everything we wrote only until 6, 7.
so actually there is one more decimal also. But mostly while while doing the sums also, if in the bracket the mention means no problem. Otherwise, 6.673 into generally it is Newton by Newton meter square per kg square is. We will get this equation also. This unit, suppose if you feel difficult to remember, like I said on that day, we'll just separate g from this equation, and from that only we'll get the units.
Okay, sir.
So suppose if I separate g from that, I cross multiply it. So finally the equation is given as going to be f is equal to g m1 m2 by r square. F is equal to g m1 m2 by r square. So sometimes teachers may use small m, capital M for the masses, or m1 m2 our wish.
Okay, sir.
So Pranavi, this particular force acts in the line joining the centers. Means what simply, there are few properties or characteristics for this force. That is 100% it acts. First thing is it is universal law of attraction. Means 100% there is a force of attraction that acts between any two objects. Because the main reason is due to their mass. Actually, the force is because due to their mass. Anything that has mass, 100% attraction will be there between that mass and some other mass. So here, and the force mainly acts along the line joining the centers of the two bodies, of the two masses. Okay, Pranav?
Yes, sir.
And the next property is Pranav, like force is equal to this, the force is equal and opposite on both the objects. Means whatever this body applies force on that, the same thing will be applied by the other body objects. Okay,
Yes, sir.
simply like it follows the universal Newton's third law, which is every action that has equal and opposite reaction. Like that. Now, Pranavi, we can understand that once the masses move away from the each other, once the masses move away from each other, like means automatically the line joining the centers, the distance between the two bodies, if it is increased, means what the bodies move away from each other, means the distance between two bodies increase automatically. In that formula, now shall I delete this whatever I have.
Which one? I can't see anything.
So till now you didn't, actually till now I was writing this one.
Yeah, now I can see. Before I can't see.
Yes, Pranav. So finally the equation is Pranavi, f is equal to g m1 m2 by r square. No,
Yes, sir.
f is equal to g m1 m2 by r square. In that equation will be used. Pranavi, here if you observe this equation, g is equal to m1 m2 by, so f is equal to g m1 m2 by r square. So if you cross multiply here, g m1 m2 is equal to fr square. Okay?
Yeah.
So g is equal to fr square by m1 m2.
Yeah.
So now when we f unit, we know that it is Newton. force.
Distance is meter and then kg, below it's kg.
Pranavi?
And then the denominator, it's kg square.
Yes, Pranavi. R square is equal to meter square. M1 into kg into kg. Kg. So that is how the unit will go. Newton meter square per kg square. And its value is given as 6.673 into 10 power minus 11 Newton meter square per kg square.
Yes, sir.
So now Pranavi here, so this force acts along the line joining the centers of the masses. Now let us take in this formula, radius is there. Now that is radius, it's not radius, only distance between the two bodies. That is which is measured from center to center. So that distance, if we increase, means what the bodies move away from each other. Means what will be in the denominator already. If suppose if a value is increasing in the denominator, numerator same will be those two masses. So G is already constant. We know it, no? So let us take now numerator. Suppose both the masses, if one mass is 25 kg, another mass is 10 kg, right? Total 250. No product. Is that happening?
Yes, sir.
Now G is anyways constant. I'm just keeping G like that. Now for this masses, distance, initial distance between them is 10 meters. Suppose. So 10 square denominator 100 will come. No? Is that happening?
Yes, sir.
So now what is the answer, Pranavi? It is 0 per 25 by 10 2.5. 2.5 into G. No?
2.5 into 6.67 into 10 power minus 11.
Yes, Pranavi. So just for understanding, as of now, can I keep 2.5 into G?
What?
G value I am not substituting as of
Oh,
now.
okay.
Pranavi, now one more, no, same thing, same masses. Pranavi, we are increasing the distance between them. Means we are moving the one body or another body away from each other. So automatically, once the distance increases, what will happen is, so the denominator, let us, before it was initially 10 meter. No, now suppose if we take it 20 meter, what will happen is to let us take um, 10. Okay, for our understanding, I'll take easy because denominator I am checking that only 10 will come 100 or 1000 like that. So 100 meter. So denominator now how much it will become, Pranavi?
100 into 100.
So 10,000, no?
Yeah.
So 1010 cut. 25 by 1000 means 0.
0.02.
Yes, Pranavi. Means 0.025 is bigger or 0.25 is bigger, Pranavi?
2.54 is bigger.
Yes, Pranavi. Means 0.025 is very smaller value. When you multiply that with G also, anyways 100%, 2.5 G is bigger than 0.025 into G. Because 0.025 is less than. So what we can understand from this is Pranavi,
If
F
the objects
value
are nearer to each other, force of attraction is more. If they are
is.
farther away from each other, the force of attraction is less.
Yes, so we can understand that the force decreased as the distance increased between the two bodies. Okay, Pranay?
What?
The force of attraction decreased between the two bodies, between the same two bodies, once the distance between them is increased.
Yeah.
Okay. So, like this, it's a long range force also in part. Like there's a little attraction between them. They're very far also. Okay, Pranay?
So,
Very little. As per the fundamental principle, that is, it's like since masses exist, the gravity, that is attraction exists. So because of this principle, okay, now, like we know that, shall I delete this? Okay?
yes, sir.
So here, we that suppose if the like we are able to stand because of this principle only, the gravity between the human mass and the earth. Okay, Pranavi?
Yes, sir.
So here, Pranavi, is there is one thing called Pranavi, like suppose how can we define this?
What?
How can we define this universal gravitational constant?
Sir, I think it's there in the printed notes.
So it's there. Once I open the
Yes, sir.
so we'll make all the values equal to 1 and we'll look at. You might get one doubt. If there is attraction between every two bodies that exist on the Mars, they should attract each other like that. So here the thing is maybe that is correct only, but the thing if you observe the G value F is equal to G m1 m2 by r square. No? Clearly we can see the masses, two bodies like let us ball is a very big one. Suppose ball has so much mass, then if that is true means that every body should attract to the ball. But the thing is, Pranavit, the thing that is multiplied, the one that is multiplied with this result, whatever that is multiplied with G, no? So here this G is a very small value, 6.673 into 10 power minus 11, negative power. Negative power means what if I write this thing in the denominator, it is by 10 power 11. By 10 power 11 means here is 11 zeros will come.
Yes, sir.
Some means 6.673 by that much bigger number, you will get this result 0.000000 like that. No?
Yes, sir.
So that when you are multiplying anything with 0 point that is lesser than 1, 0 point means this value is finally lesser than 1, very small value.
Yes, sir.
So that how much bigger number you are multiplying with also m1 m2 by r square, how much bigger it is also finally it becomes very small because you can check
But then
suppose
how is the
so
force
final
action between a magnet and an iron object really high? Like when we put them close to each other, they attract each other, even when their masses is low and like the gravitational force is the same.
when we actually there because of the alignment of the atoms inside that there's a different case the magnet one there we have means 100% normal if there is any mass also attraction will be there but magnet attracts to the iron because magnet has its own properties the alignment of atoms because of that inside that that particular magnet has its own like only because it attracts only few type of things only not going to be like iron it cannot attract wall it's not going to be
Yes.
so here their magnet only attracts to the some type of items only like iron that kind of thing because the alignment of atoms inside or some other few other reasons for there inside.
Oh,
So there will be two terms I forgot suddenly I'm not recollecting. Because of that that force we can feel it with heavy actually even though it is a small magnet it attracts to the iron you're telling me.
yes.
Yes, that is because of because magnet attracts to some type of materials. Yes, ferromagnetic like that something in the so because of that their attraction happens.
Okay, sir.
There also
So,
again if you observe big if you take a very big magnet it attracts so fast. Means with heavy force it attracts.
yeah.
So there also again it depends on the mass of the magnet. That particular attraction also it depends on the mass of the magnet. Same iron plate you can take. Small iron, a small magnet you can take, big magnet you can take. Big magnet will attract with heavy force
Yes, sir.
because of its heaviness.
Yes, sir.
Actually, so here because of this directly, because suppose unless we touch the wall is not directly attracting us. There is a force between that wall and us, but the thing is, it directly cannot. It's very less. So it's not sufficient like how we are holding our leg on the earth because it is a very big body. So we are able to attract it because of it is able to hold us because of the gravity. But wall there is a force between the wall, which is the wall and us also. But the thing is, that particular force is not sufficient for the wall to attract now.
Yes, sir, I understood.
And now, Pranavi, this F is equal to ma is there. No, Pranavi?
Yes,
In
sir.
this equation, now all whatever the things that we deal with free falling bodies. Free falling bodies means suppose if you just hold some item and if you fall, if you just leave it, that is called as free fall. Means you're not giving any force for them separately. You're not just
Yeah.
understood
Yes,
what
sir.
I'm trying to say.
Understood. Understood.
Yes, it means free fall means its initial velocity is zero always. You're not applying any force on it. Just it is coming down because of the Earth's gravity.
Yeah, I know.
So here, suppose you just hold a body, you just left it in the air, then it will 100% fall to the ground. This is the case, suppose. So here, in this case, Pranavi, even though you didn't apply any force while leaving the body, since because of the gravity, when it is traveling, like we know just now from that the physical g m1 m2 by r square, as the distance increases, the force decreases. So, not Pranavi?
Yes, sir.
As the body comes closer to the earth, as the body comes closer to the earth, what will happen, Pranavi? The distance between them decreases, no?
Yes, sir.
So force should, so distance decreases means force should, what will happen, Pranavi, for force?
Force should increase.
Is Pranavi. So because of that reason, it attains some acceleration. That acceleration is only, means there is a change in speed automatically
Yes, sir.
because force of attraction is increasing. As
Yes.
it comes closer to the board, closer to the earth than its initial position. So because of that reason, automatically when force of attraction increases, its speed increases. That is velocity increases. So initially, even though you didn't provide any velocity for that, when it hits the ground, suppose someone is there, someone's leg is there, or like some, when it falls on it, automatically hurt will be there because of the heavy force. As it comes closer to the earth, attraction increases, force increases because of that speed increases, then because it will have some momentum because of that all that reasons. Finally, a person, suppose if it falls on the person leg or something, he'll feel the force automatically effect.
Sir.
So now,
Yes, sir.
so here, because of that, here this F is equal to ma. This acceleration, whatever the body gained, is because of the gravity of Earth. No?
Yes, sir.
So this A word, that is A, will be changed to G Pranavi for all the cases where free falling cases. Suppose if a body, if suppose any body is falling on the ground, in all such cases.
Okay,
Okay,
sir.
Pranavi. So that A will be changed to G for all those cases. Any doubt, Pranami?
No, sir.
Because acceleration attained by the body is due to the gravity. There. And 100% there is a gain in acceleration because it's as the distance between the object slowly reduced, force of attraction increased because of that speed, it gains velocity.
Yes, sir.
And because of which automatically all that will be the momentum and all. Finally, F is what energy will be there. So both are for all the bodies, free fall bodies. That is, if anything is falling on the ground, in all such cases, A will be replaced with G Pranavi, and G is given as universal. This is gravitation. That is acceleration due to gravity will call them because of the acceleration due to gravity. Because the acceleration gained by the body is due to the gravity of the.
Yes, sir.
So the A will be replaced with G. G is given as maybe 9.8 meter per seconds. You can see it's a very, it's greater than G. It's greater than 1 inch.
Yes, sir.
Because of that reason, if we just freely leave the body also, it will gain acceleration. That is due to
Yes,
the
sir.
speeding process. But as it comes closer to the body. Yes. So now when we
Yes, sir. So you asked for the definition of the universal law of gravitation. It's there. It's there in the printed notes.
say
Yeah, it's there.
it's So Pranavi, in this just we'll separate the G from the equation and we'll make all the unit, all the things one, Pranavi. What is the meaning of that is, suppose imagine to understand the G clearly, what they will do is like this. If I separate G videos up.
Sir, it's not a blade.
So F is equal to G M1 M2 by R square.
Sir, it's on only. You can't see it.
No, Pranavi, suddenly it so from this Pranavi, if I separate, if I cross multiply G M1 M2 is equal to FR square. G is equal to FR square by M1. Okay, Pranavi? Any doubt, Pranavi?
Sir, now can you see it?
Yes, Pranavi. So now Pranavi, in this, suppose if two masses have 1 kg, if M1 is 1 and M2 is 1 kg, or the distance between them is also 1 meter, then the equation will become what, Pranavi? F is equal. Then why we should take 1 like that? You will get it out. So Pranavi, generally to understand the things, for example, let us take you want to buy 10 ice creams or 10 chocolates or something you want to buy. Generally, what we will get in our mind, we will calculate it as per the quantity which you want based on unit item cost always.
Yes, sir.
So like that here also, to understand what is the thing effect on unit things, then we can understand how it will, how the effect will be for different masses. That multiplied GM1 understood what I'm trying to do. Because
Yes.
of that reason, they'll always not only for this, from now anything they're defining in physics, they'll take like this.
Okay.
Any constant or anything, any term they are defining means suppose even force also. Force when we learned M into A, to understand units of force is one Newton, no? Maybe.
Yes, sir.
So any quantity to understand the thing clearly, they'll first define it. So how one, what is the effect of 1 Newton? They'll define 1 Newton there also. How they'll define is both mass and acceleration. They'll take it 1 1. Okay, Pranvi?
Yes, sir.
You need a body of, if suppose if a body of 1 kg travels with an acceleration of 1 meter per second square, whatever the force generated is said to be 1 Newton like that.
Okay.
So anything they'll take define it based on that by considering unit values. So here F is 1 Newton per meter. I'm just substituting in this formula in the place of F1 and R square 1 square. So sorry, we are this G is because of F, no, F will be F1. We are just understanding the force if the how the bodies if the bodies have 1 unit, all of them have one.
Yes, sir.
So F into R square is 1 square 1. So in that case, Pranavi, G is equal to F into 1 square 1 by 1. So we are getting an equation like G is equal to,
F.
which means what, Pranavi? Whatever the force of attraction that is there between the two bodies of 1 kg, if they lie at a distance of 1 meter, that particular force is said to be the value of universal gravitational constant.
Okay, sir.
So in that way, this one they said here like m is equal to 1 unit, and both the masses 1 unit, radius also 1. Then G will become equal to F as per the from the equation. So they said that it's defined as a force of attraction between the two bodies of unit masses separated by unit distance.
Okay, sir.
They took unit here. Unit means it can be 1 meter or 1 kilometer or like that. So similarly, this is 1 gram, 1 gram, like as per that. Unit
Yes,
can be
I
all of them
understood.
same.
Yeah, I
Yes,
understood.
yes, ma'am. So if it is a SI unit means that will be kg, this will be kg, this is meter.
Yeah, I understood.
Okay. Ma'am. So finally, in that case, they found out the value of G as 6.7673 to 10 power minus 11 Newton meter per kg.
Okay,
Suppose we want it for 10 kgs means we will multiply with this. one item is 10 rupees means 5 items is 5 into 10 like that.
Yes, sir, I understood.
So the value of G is same throughout the units.
Okay, sir.
And there is they they explained about centripetal force also, Pranavi. The centripetal force is the one which is a central force we'll call it. Central force. Central force means, for example, if suppose someone is traveling, suppose simply to tell maybe there is a giant wheel or something is rotating, no?
Yes, sir.
There is a force of attraction towards the center always. Because of that reason only that will be stable. Otherwise, what will happen is,
Like the earth.
Pranavi,
Like earth.
yes, Pranavi, we can take that is the best example. So sun, Earth rotates around the sun, no, Pranavi.
Yeah.
So it's if suppose there is no centripetal force towards the center. Center means the attraction between the sun and the Earth, which is moving.
Yeah.
So then automatically the Earth will not be stable.
Yes, sir.
So when it is generally at that point, if you take suppose this Earth is here since it's moving, the direction of the speed will be given in the tangential. Tangent means if you draw a tangent at that point, in that direction speed will be there. Suppose suddenly if there is attraction between the sun and Earth is gone means if there is a this Earth move like this, it will move away. We can just take means we can verify this with some example with some random experiment also. Suppose for example if there is any thread probably, and if you hold any, if you like tie any small stone in the last of that, and we will hold the thread here and we'll rotate it fast,
Yes, sir.
then we will get a circular motion.
Yeah, but when we cut the thread or something, like it
Suddenly if you leave it,
flies.
suddenly if you leave, if it means if you're removing the contact with the thread suddenly.
Yeah.
So this stone will move in the tangential path because at the position where the stone is when you left that, from that position it will move in the tangent straight. It will
Yes.
move up. So here that only is the center. So until you left it run away, that is clearly you're holding it, no? So the stone was in under the control at the center.
Yes, sir.
That is where you have hold that one, that pointer, the control was there. So similarly, the same thing here also. The force which keeps the body in the circular path acts towards the center of the circle. Is called as centripetal force.
Okay, sir.
If there is no centripetal force, the body will move in a straight line tangent to the circular path. So this we can clearly observe also with the experimentation of it, the one which the thread one. If you leave it suddenly, it will the position where it lost contact when you left no Pranavi, from there it will move tangent straight, fast, straight.
Okay, sir.
Yes. Until then it was in circular motion. If we left it, it will move up.
Okay, sir.
So Pranavi, formula for centripetal force is the formula for centripetal force is Pranavi, where m is equal to, I think it should be centripetal force
I
that
think
is
there was some print, like I think there was some error and like it didn't print or something. What is the formula, sir?
actually this also we will get it from f is equal to ma only. Okay. Okay, Prithvi. So finally, the formula will come like for this, maybe some we will apply some different things. I think this is here something is missing. I remember it as F is equal to mv square by r something like,
Okay.
where m is the mass of the object, maybe, and v is the velocity with which it is moving, and speed of the body. R is the radius that is centered to that body.
Okay, sir.
Any doubt, Pranav?
Sir, I understood.
So formula is MB squared by R. I think I remember correct only.
No, okay, sir.
And this universal gravitational constant, the value of G was determined by Sir Henry Cavendish, this person. Since the value of G is very small, so the gravitational force is a very weak force. You can see this point before I was taking.
Yes, sir.
It's a very weak force. Because of that reason, directly we are not some other heavy body also cannot attract directly us.
Yes, sir.
But there is a force.
Yes, sir, I understood.
Okay. So now, the importance of universal, this only the characteristics or the like importance of this is the gravitational force is responsible for the existence of solar system, because solar system has that all the planets are moving around the huge mass sun of Pranali.
Yes, sir.
So because of that attraction only, it is there. That is what this law is explaining. Right?
Yes.
Correctly explained, law successfully explained. And since it's law Pranavi, 100% it is it has to be believed, and it's clearly visible also because of the you know.
Yes, sir.
Then similarly, all these tides in oceans are formed due to gravitational force between the moon and the water in the oceans. And the gravitational force between a planet and its satellite decides whether a planet has a moon or not.
Sir, what?
Gravitational force between a planet and its satellite. So generally, when we for Earth, generally moon is considered as a natural satellite, I think,
Yes, sir.
or artificial, natural. Yes. So like that, gravitational force. There is a gravitational force between the Earth and the moon, for sure.
Yes, sir.
Gravitational force between a planet and its satellite decides whether a planet has a moon or not.
Yes, sir.
Okay. Need some deep understanding, but anyways, so here importance of universal law of gravitation. Okay. And the atmosphere of the Earth is possible due to gravitational force of the Earth.
Yes, sir.
This also, this also in a way we can this rainfall and snowfall is possible only due to gravitational force. The object stays on the Earth due to gravitational force between the Earth and these objects. And one more is there in between. Artificial satellites. Artificial satellites revolve around the Earth due to the gravitational force between the Earth and the satellite.
Sir, it's there, right? It's given there.
Okay.
It's given there, the fourth one.
It's given there in the
Fourth one.
history. Fourth one is about the natural satellites. Means natural means generally the Earth has natural satellite. They'll tell like more. Okay. So here fourth one is like artificial satellites, which man will like which um, they will prepare. I mean, like generally, physics scientists and all will do natural like artificial satellites. They'll send around the atmosphere of the Earth. Like all this internet and all, like this means TV and all the direct signals we are getting. I mean, that based on the artificial satellites.
Okay.
So in that way, like they what they will do is these satellites they will send it to the atmosphere that is around the atmosphere. So up to certain extent, from there we will receive the signals.
Okay, sir.
Actually, videos are.
What? Oh, sir, it's suddenly getting off. 1 second, I'll turn it.
Actually, in the sums we have, I think, based on that, okay, we have few sums on this also.
Yes, sir, we have a lot of solved examples and like uh They gave a worksheets also.
In the above worksheets also. Maybe?
Yes, sir.
Yes. Actually, there is a lot of understanding how to convey in this, because they gave so much things, but anyways, we can do.
Sir, so tomorrow will we finish it, the chapter? Because the
I
exam is on Friday.
anyway,
Because the exam's on Friday.
mostly means now I think maybe suppose for example if there is a someone it is called to GM1 M2 by asked, how can we do it maybe from the question first we'll write the values that are given and then we'll what is not given we'll write is equal to question mark and from that equation we'll try to find out it.
Yes, sir.
And especially assertion reasoning these ones based on the things maybe that is like few things like, if you just learn the theory means that points and all if you remember nothing assertion and reasoning in that there and no, still we have more 1 hour, no? We can finish the entire outline for this for sure.
Yes, sir. Sir, actually in our notebook, our physics sir made us write equations of freely falling body. The from the three equations of motion, he just replaced A with G. So like
Yes,
we got B is equal to U plus GT, H is equal to UT plus half GT square.
yes, no, correct.
Actually, there U is equal to 0, so we only got V is equal to GT, H is equal to half GT square, V square is equal to 2GH.
Yes, for all the freely falling bodies, A will be replaced with G and initial velocity mostly will be Z. Not mostly, all if it is a freely falling body, U will be 0. So in all these equations, we will become 0 means finally you will get first equation will get A, B 0 plus 8A actually, but A will be replaced with G. So V is equal to GT and S is equal to UT plus. So finally at the point where the body hits the ground, at that point, what is the velocity means it is given by V is equal to GT.
Yes, sir. Actually, sir, there is another question. An object is dropped from a height of 19.6 meter. Find the velocity just before touching the ground. He used the
Yes.
formula V is equal to root 2 GH.
We once you read one more time the question.
An object is dropped from a height of 19.6 meter. Find the
Yes,
velocity just before touching the ground.
yes. So since it's dropped from me, U will be 0, no?
Yes, sir.
So V is the velocity here which we need to find out when it hits the ground.
This is just before touching the ground, right?
Yes, V value. V value once it touched the
Yeah.
ground, because it's the final velocity when
Yes.
it touched the
Yes, sir.
ground.
Yes. Okay, sir.
When it hits the ground like that, when it
Okay, so
touches.
this formula is V square is equal to 2GH. He just redirected it to root 2GH.
From this A will be replaced with G. S will
Yeah.
be replaced with height only, the height from which the distance or the height it traveled. So finally V square is equal to 2GH with that. V
And
is equal to root 2GH.
yeah, root 2 into 9.8
Into 9.8 into
into
19.
19.6.
Yes.
And
So
then
this
2 into
value
9.8 is 19.6. So root 19.6 into 19.6. We remove the square root. It will be velocity is equal to 19.6 meters per second.
is that is correct. 19 meters. Yes. So that is the velocity finally when it hits the ground with or when it
Yeah.
okay.
Yes, sir.
Actually, it is means when it touches the ground, it will have that velocity.
Yes, sir. Sir, our class is only until 3:30.
Yes. Actually, that one regular class is for me, that's right.
Okay.
Means actually when we keep the alarm at 3:30, so that's why alarm came before. But today our class is means normal class, no? General class, normal classes will start at 3:30 normally.
Yes, sir.
Means if it is also over means I think for few is coming. Again, afterwards, normal like that.
Yes, sir. Okay, sir.
The student exam is not finished, maths, other classmates,
Oh, okay, sir. Sir, which grade?
7th,
Oh, okay.
present, sir.
Okay.
12th it is. For your 12th science.
What?
For your 12th science, for the maths. So 7th grade maths is on 12th. For us on science on 12th.
Oh, okay. Okay. Bye, sir. Thank you, sir.
Tomorrow is at 2:30 to 3:30.
Okay, sir.
No, bye.
Bye, sir. Thank you, sir.